Okay, I'll quickly show how to install the EDA tools, WSL and Ubuntu, and install the EDA tools. I actually have most of it installed already, so at least I'll show you so that you can get familiar with the user interface. The first thing you want to do is log on to our portal, which is github.com/VLSI. If you go here, the first one will be our analog IC design. So I will just click that. So probably keep a bookmark link for this one. We'll be using it a lot. So this is our portal, which has all of our contents, and you can see there's two installation files, which I have mentioned in the install instruction, plus a BAS-RC file, which we need to include within .bas-RC. So let's go right to the Ubuntu WSL, and at least I'll walk you through. So the first thing you want to do is check your minimum Windows requirement. I think for most, almost all, this should be okay. Make sure, typically this is BIOS enabled. If you're having issues, you can come back and check, but this should be by default enabled in most BIOSes, but it's probably a good idea to check it. And then this too needs to be enabled in your control panel. So if you go to your control panel, the control panel, and then programs, and in this you'll see a turn Windows features on and off. If you click that, you'll come up with a dialog box, and if you go towards the end, you'll see Windows subsystem for Linux right here, and that should be enabled, and the virtual machine platform, that should be enabled as well. I think these are the two you probably need. After doing that, reboot it, and then start the PowerShell as admin. So if you right click on the Windows, by the way, this is Windows 10, 11 should be pretty much the same. Right click, Windows PowerShell admin mode. People working in user directory where they don't have root access, you probably have to give you a password for it, and I hope you remember that. The first thing I would do is check the WSL version to make sure it is 2.+, because some of the older ones might still have 1, and that won't work. So WSL means version, so this means version. And you see here it says 2.5.7, and that's the latest one. 3 days ago I updated it. If you have 2.5.7, I don't think you need to update it. Otherwise, good idea to update it. It takes a while to make sure you have a good connection, battery is charged, your power, and all that stuff. And then once the update is over, you can shut it down. And then you need to install the Ubuntu. So first find out what are the distributions available for Microsoft WSL. So we type WSL --list --online. You can just copy and paste this line right here. And if you hit enter, yeah, so these are all the distributions available. The one you want is 24.04. So you go WSL minus install -d. Copy and paste this. Okay. I will not do it because mine is already installed. I'm just showing you how to do it. So once this is installed, if everything goes fine, and when you start Ubuntu, you would go to your Windows Start button, and on this recently added one, you should see it up here. I will just pin it to the start. I already have it started. And then when you start for the first time, you'll be actually asked for a username and password here, one-time username password, and that will be your sort of your root username password. And I suggest you name that as Ubuntu because that's the standard naming convention for Ubuntu. So once it's up and running, you'll get a shell like this. And the first thing I would do is update the Ubuntu now. The WSL is just a virtual machine. So it's like your desktop. The WSL is like your desktop. So you have kind of updated your desktop. Now you need to update the Linux itself by typing this command sudo apt update, which will get all the repository updates and then upgrade to all the packages that will get upgraded. And this is definitely needed before you start doing anything. Otherwise, you might end up with issues with libraries, old libraries, and stuff like that. And then again, shut it down, WSL. So go to the PowerShell window and do a shutdown here. And after it's shut down, then you can start your Ubuntu again. And that's it. So that you're done with setting up WSL and Ubuntu. So you have the base Ubuntu now. And so the next step is to install the EDA tools. Now, please don't install EDA tools by typing sudo apt get install xschem and ngspice, because they're older versions and will run into issues with SKY-130 technology, the technology we're going to use. So I compiled both the tools for 24.04 along with Magic and xschem, which we'll do at a later point of time. So you just follow the steps. So go to the second link here, follow the steps to install and set up EDA tools. So if you click this, the first step is updating WSL and Ubuntu, which I just showed you. So you can ignore that right now. And then the second one is cloning our GitHub page. This page right here, what you're seeing, you need to clone it. So you type git. Actually, you can just copy and paste this command right here. You type it and it'll start cloning our portal page. Take a little bit while. And once that's over, okay, so that's done. And if you type ls now, you'd see this directory called SI-2025-AnalogIC. And if you go into this directory, you'll see some files here, which are basically the files in what you're viewing here. So in this page right here, so you can see there's a content folder, docs folder, xschem folder, and some files over here. And that's exactly what you see over here as well. And these are obviously rendered. So this is the file you're viewing is actually this readme.md file, which is obviously rendered to this nice looking format here. Okay, so once you've done that, there are two scripts, this install libs.sh and install eda.sh. So the first one will load any missing libraries. There are, I think, 4 or 5 of them, which I found when I was installing on a fresh install. So I put that in that script. And then the EDA tool will be the ones I have compiled it, but not only it downloads the EDA tool, it's also sets up all the xschem directories and spice in it, xschem so that you don't have to manually do it. And then finally, the environment variables need to be sourced in your default basrc.basrc in your home directory. So you need to put the content of this file into this file here, your file. Okay, and that should set you up. All right, so let's do that. So now one thing is I have mentioned over here, do not work in this directory. So this SI-2025-AnalogIC, this will be the one will be just for your reference, because I'll be continuously almost on a daily basis updating this. So all you do is you go to this directory and say git pull, okay? And obviously it says already up to date because I just pulled it. But don't make any changes here, then you'll have conflicts and all that, then you have to delete it and clone it again, okay? So this is just for the reference. So now the first thing we'll do is copy both the install files. Let's say install star to this home directory here, and you see these two files here, but they are not executables right now. They just have read-write permission. So in order to make it any executable in Linux, it's pretty easy. You just add the executable permission saying append executable permission to do this file. So you say install start. And if I do ls-l now, you can see the executable permissions are here. And in Linux, you would see the color turns to green. So that typically tells you that those are executable. So let's first run the first one, install libs.sh. And last for the root password. This one you need root password because it's a system install. So I'll give my root password here. And it says all these are installed already because I've already done it. In your case, it'll install it, download and install this package. So once that's done, the second is the tools itself. So if you find, so it's basically saying Ubuntu Share exists, xschem exists, all this exists because again, I have already installed it. In your case, this will be downloading the JIT and installing it. And after this, your directory structure is going to look kind of like this. So you obviously have this portal, and then you're going to have a cat directory underneath that. You have the ngspice installation, and then you have the xschem installation. And in the share directory, you have the process design kit, which is all our technology files like spice model files, layout rules, and all that kind of stuff is kind of trimmed down, compiled, and put here. So because this is a really long and arduous process of doing this, so that's already done for you as well. And then I've created a work directory, work xschem, and I put the initialization file in that directory as well. Okay. And then you also have the simulation directory, which xschem creates it in .xschem. So you see there is a file called .xschem in your home directory, and there's a simulation directory. And obviously, I already have some files over here, but in your case, this should be empty with just one dot file called .spice in. Okay, so if this is all done, you're all set with uh, installation. Okay, the next thing you want to do is copy. There's a file in this SI analog IC called basrc-EDA, and if you sort of see the content of this file, just to cat basrc-EDA. So if you see the content of the file, what it is doing is it's going to the xschem installation directory, and I've created a basrc xschem where all the environment variables are there. And similarly for the ngspice. So all it's doing is actually sourcing from the directory over there. So what you can do is you can open .basrc, and you'll see I already have this over here. So I've already copied and pasted that basrc file over here. But if you don't have it, I mean, when you're doing it for the first time, obviously you won't have it. So you can just, the simplest way to do is open up in any editor you're comfortable with, Vim or Nano, and then go to this file called basrc-EDA, and you can just copy this file and just paste it in your window, and you would get this file. And once you're done that, you just source it. You don't have to do the sourcing business all the time. Any new window which comes up with automatically source. But since I just added it, I mean, in my case also, I won't need it. But in your case, when you first time add it, you just do a source.basrc. That will source everything. There is no error. That means all your one thing, maybe I should show that. Okay, let's just show you. So, yeah, Nano is not a problem. People who are opening in Vim RC, I'll show you one issue where this is to do with the way automatically it is set up. So when you copy and paste it, you'll see that everything is commented out. That's because these first two lines are comment lines. And because of that, every new line gets commented out. So actually, let me do one thing. Let me fix this on the source itself. Okay, I don't have the root access here right now, so I'll fix this. I'll remove the comment so that you don't have that issue. So that way you'll just copy the commands and paste it in .bash RC. Something I wanted to show you. So, okay, so if everything is set up, now you should be actually able to run, open the schematic editor and start running simulation. So let's check it out. So the work directory I've created is from your home directory, you go to work, and there's a folder called xschem. And if you do ls, you'll just see there is a xschem RC file here. And that's the initialization file, which is automatically put when you run that install script. It has all the PDK references and library paths for xschem in the install directory for xschem. All right, so all you have to do is type xschem, hit enter, and if there are no errors, you can check here. This warning you can ignore, and it looks like it started fine. So, and this starts with a default schematic of the Sky 130. So you can see almost all the devices of Sky 130 and how to instantiate command, text for ngspice, model files, and all that. And there's a little cheat sheet here as well. All that is in the file. So it's a nice reference for you. You can just do copy paste over here. So for this particular purpose of testing the EDA tool, I would, so just a quick navigation. I know it's probably first time for everyone. So type F to, so if you're zoomed in and you want to zoom out to the full screen, type F. And if you want to zoom into an area, you right click, hold, and drag to the window size, and you release it and it'll zoom to that area. You can put a cursor and run the middle mouse button. Those people who are going to use mouse. If you're on the laptop, then you can't do this, but this is what you do. And then if you have the mouse, you click and hold the mouse button and go left, right, top to pan it and then forward. So that just a quick introduction how to. And then if you zoom into this left, sort of the top corner, you'd see a test circuit because a lot of the test circuit are not working for some reasons. Not a lot, but some of them. This one works fine, so let's go into this. So if you click and select it, and then you push into the schematic by clicking this button here, and you would go into this schematic, which is a ring oscillator. Okay, so this is already set up to run. And on the top right corner, you'd see three buttons, netlist, simulate, and waves. So the first thing you want to do is netlist. And if it netlist fine, you'll see this green. If there was an issue with netlist, then it will turn red, and then you go to the directory, simulation directory, which is the .xschem simulation directory, and find out what the problem is. And then you hit simulate, it will pop up with this external window and started in ngspice. It said no such command with something in the spice in it, which is not working, but it don't work. So, and the window disappeared because in the control commands of the spice, it's a quick command is given here. You can see quick 0. And typically when we are going to simulate, we'll not put that because we want to see if there was an error or whatever output of that file is. Okay. So, and you can see the nice thing about xschem is you can actually embed plots in it. So there's already some plots embedded in it. And this was a transit simulation. So what you can do is now you can go to waves and load the transient file. So the file where the output is written is this testin.raw, which is actually given in this command file. If you look at right here, it says transient run and then write test raw.raw. Test underscore in.raw. So load that file and you can see that it actually loaded the waveforms. And if you click the waveform here and you can navigate it, I'm not still figuring out how to navigate through these embedded windows. But we can use the spice plots as well, the embedded plots. So I think that's it. If you can get till here, your xschem and ngspice is, your WSL, Ubuntu is working, all the libraries are loaded, all the softwares are loaded, all your environment variables are set right, and your directory setup is set right, and basically now you're ready to simulate. For the layout part, I'll give that instruction later when we get to it, and we'll probably not start that almost till 2/3 or middle of the course. All right, that's it. And if you run into issues, just send a comment in the WhatsApp, or you can ping me during the class.